There are four ways of representing numbers in Sanskrit. The first way is the general system of numeration. So, what is the general system of numeration? It is basically the system that is found in other languages too. There are names for each place value, and similarly, Sanskrit has that. The first, that is one's place value, the name is Eka, and second one, tens, that is Dasha, and Shata, and Sahasra, and Ayuta, and Laksha, Prayuta, Koti, Arbuda, Abja, Kharba, Nikharba, Mahapadma, Shanku, and so on. This is a very basic system of numeration. So let us try to pronounce pi in this system of numeration. 3.14159. So since there is a point, we should omit that. So let us try to pronounce that in general system of numeration. The decimal point that I just removed was told as Dashamalava, but let's just omit that in order to make our work easy. So the number is Navapanchashatadika Ekachatvarimshashatadika Ekatrimshadayutam. So it is a very complex or relatively complex system of numeration in Sanskrit compared to the other systems. So let us look at the second system of numeration. The second system is the KATAPAYADI system of numeration. The KATAPAYADI system of numeration is basically based on the consonant system of the Sanskrit alphabets. This was the ancient Indian or ancient Sanskrit system. So let us look at the rule of the system. In Sanskrit, it is called as Nayavachascha Sunyani Sankhya Katapayadaya Mishretu Pantyahal Sankhya Nacha Chintyo Halaswara. So it translates as Na and Ya, and all the vowels are going to represent the number 0. And the other 9 integers, that are 1, 2, 3, 4, 5, 6, 7, 8, and 9, they are going to be represented by Ka, Kha, Ga, Gha, Nga, Cha, Cha, Jha. And similarly, Ta, Tha, Da, Dha, Na, Ta, Tha, Da, Dha. So basically this is the thing, and the first 5 is again represented as 1, 2, 3, 4, 5. It means Pa, Pa, Ba, Ba, Ma, and Yara, Lava, Sha, Sha, Sa, Ha represents 1, 2, 3, 4, 5, 6, 7, 8. So this is the thing, and the other thing that it says is that the halanta swara or the conjunct should be ignored. Now let us attempt to say the previous number that we had already pronounced in the general system. Actually, there is a verse for 17 decimal places of pi. The verse goes like this. Gopi bhagya madhuvrata shrungi shodadhisandigha khala jivita khatava galahalara santhara. So it is the shlok of a Krishna which glorifies him. But if you encode or decode this with the help of the Katapayadi system, it represents the digits of pi. That is 3.1415926535889, and similarly it goes on up to 17th decimal places. So this is the another system of numeration, the Katapayadi system. This method can be implemented by the modern people for remembering ATM pin codes and things like that. Now, what you can do is convert your ATM pin code into any familiar Sanskrit word, phrase, or a sentence so that you can remember it very easily. So let us jump into the other system of numeration in Sanskrit. That is the ARYABHATTIYAN system of numeration. Now, in the ARYABHATTIYAN system of numeration, it is also based on the same arrangement of consonants and vowels. It may be the mother of KATAPAYADI system. Now, unlike KATAPAYADI system, it has a difference. The difference is that the vowel sound will represent the place values. It means it can only represent limited amount of numbers. It means it can only represent number up to 10 to the power of 16, right? And the consonants represents the integers like ka, kha, ga, gha, nga, cha, cha, ja, jha, ya, ta, tha, da, dha, na represents the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and so on. But after you reach the value of m, that is 25, from here lower it will be 30, 40, 50 and 60, and sha, sha, sa it will be 70, 80 and 90, and ha it will represent 100. So if you look at the potential, then it adds 2 more power to the 10 to the power of 16. It means 10 to the power of 18 is the limitation of this system. So let us attempt to just pronounce the earlier numeral that we had taken, the value of pi, 3.14159, and since the point is not defined in the system, let us ignore the point, and after you ignore the point, it is going to be 314159. Now how you can write that? Now look at here, gr gr kungi jha. This represents 314159. It does not have any meaning, and it is a relatively difficult way of representing numbers, and it was soon discarded by the further mathematician or ancient Sanskrit mathematicians. So basically this is the Aryabhattiyan system of numeration. So let us look at the fourth and the final system of numeration. And the fourth and the final system of numeration is known as representative system. So let us talk about this one. This is a relatively easier concept or relatively easy way to represent numerals, and it can be difficult as you think it, right? It cannot represent a vast amount of numerals, but in order to encode with the meter or poetic meter as you say in the verse, it is very helpful. For example, you have 2 eyes, right? So 2 eyes, then what you do is associate the number 2 with eye. Now the netram, that is the synonym of eye in Sanskrit, has the value of 2, and similarly akshi, it has the value of 2. That is other synonym of eye in Sanskrit. And similarly there are 4 Vedas, so the Veda number represents the quantity 4. And similarly you have 5 senses, so Indriyani represents the number 5. And in this way this system is also very helpful for poetic works. Which of this system is the most interesting system? Let me know down in the comments section below. Thank you for watching. Please subscribe to my channel if you appreciate my work, and hit the thumbs up and bell icon.